Okay, so somebody had a question about polynomial long division, so we're going to do an example, and in this particular example, we end up getting a remainder, so maybe that'll answer some questions as well. So we have 9a cubed minus 3a squared minus 3a plus 7 all over 3a plus 2. Now, the way we're going to do this is we're first going to rewrite it like this. 3a plus 2 divided by 9a cubed minus 3a squared minus 3a plus 7. Okay? So here's what I'm going to do. I'm going to look at this furthest left term right here, the 9a cubed. Now I want to ask myself what I can multiply this first term here by to get that. I'm not really even concerned about the 2. Well, I know if I multiply 3 by 3, I'll get 9, so I'm probably going to have a 3 up here. A times what equals a cubed? Well, if you remember with our exponents, that's just a to the n, plus, we add our exponents. So that's just going to be a squared. We have 1, and we need to add 2 to get to that 3 exponent. Okay, so now what I'm going to do is the 3a, I'm going to multiply the 3a squared by, I'll do it over here. Just a little side note, so side. I'm going to take the 3a squared, and then I'm going to multiply that by 3a plus 2, what I have over here. So what do I get? I get 9a cubed plus 6a squared. And then I'm just going to put that down here. 9a cubed plus 6a squared. And I'm going to subtract that from here. So distributing this negative, that just changes this. Notice that this bit cancels, which was kind of the point. Now, negative 3a squared minus 6a squared, that's minus 9a squared. If we do this bit, right? And then these guys down here, they just drop down. There's no terms that we're adding, so minus 3a plus 7. Now again, just like normal division, we're going to do the exact same thing, except now what we're going to look at, I'll highlight it in yellow, is this guy. I want to get it to where if I take away some multiple of my 3a plus 2, the negative 9a squared cancels. So just like we did before, and this is just like normal division, just with variables, we're going to see, okay, well, again, I'm going to want to multiply by a 3, this time a negative 3, because of the sign difference. 3 times negative 3 will get me my negative 9. And then how do I get a squared when I have a? And again, I'm just looking at this bit. Well, using the same way we did before with multiplying exponents, if I have a and I need to get to a squared, I just have to put 1 there. So if we multiply, if we do go over here, we can do it again. Negative 3a, and then we multiply that by our 3a plus 2. That's minus 9a squared minus 6a. Okay? So down here, minus, and then what we just did, minus 9a squared minus 6a. I'm going to go ahead and distribute the negative to each term. Okay? So I'm going to erase that bit. That makes this positive. That makes this positive. And now we can add. And just like before, this bit cancels. And we're left with 3a, because minus 3a plus 6a is just 3a plus 7. Okay. And again, what we did here is we just brought down the 7. Just like with normal division. Hopefully you can kind of see the parallels. And again, we ask ourselves, can 3a plus 2 go into 3a plus 7? Yes, one time, right? Hopefully, once you do this enough, you'll be able to not have to think too much about it. And then we would say, well, one time, because to get the 3a to cancel with this 3a, that's just 3a. You don't have to add or multiply anything. So that's minus 3a plus 2. And distributing the negative. And real quick, just talking about this, we are subtracting it, and sometimes students will miss the fact that this negative here, in fact, I'll even make it red. This negative, it's a big red negative, that distributes to, oops, don't want to erase. That distributes to both terms, the 3a and the plus 2. So I'm going to erase this just to clean it up a little bit, but just know that we are subtracting. And again, we see the 3a's drop, and we're left with 5. Okay, so now we want to ask ourselves, can we multiply anything by 3a plus 2 to get rid of this 5 constant? And we can't, because if we multiply it, we'll have this a term if we look over here. If we multiply by some fraction to get rid of the 5, we'll be left with a. So this is as far as we can go. And the way we write the solution is like this. So in blue, because that's this part, so what's at the top, we write that down first. So 3a squared minus 3a plus 1. That's just this bit. And then the way we do the remainder is we say plus 5, because of this guy, all over what we were dividing by, which is this guy. So 3a plus 2. And there you go. There's your answer. So the way we do polynomial long division is we first rewrite it like this. And then just like with normal division, when we have, if we have 5 go into 25, we ask ourselves, how many times does this go into this? Well, 5, and then we subtract, right? It's the exact same thing. The only thing you want to keep in mind is now we're working with variables. So you also have to keep in mind our exponent rules, which I'll box here. And then you just keep going and going until you can't go any further, until you have a remainder. And then the way we express our answer is just the top, right here, this box little thing, plus our remainder divided by whatever it is we were dividing by. In this case, it was 3a plus 2. So hopefully that makes sense. It's not too bad. And yeah, I can do more of these examples, but I wanted to go at least detailed in one of them.